the first page, I'm just going to mention briefly a few things about this first page. You will learn a lot about these elementary functions today when we're doing graphing, because that's all we're going to focus on today is graphing. It's a big section about transformations. The more of these graphs you get memorized, the faster you'll be able to do this. But we're going to talk about those things as we're graphing. Okay, so let's go on. Let's go to page 2. All I did was the first 2 examples. I'm just going to start that again. So the first thing I'm going to talk about is what we call a vertical reflection. And you'll probably catch on to this. What usually students have trouble with is that after I go over it, it'll kind of start getting a little bit mixed up in your head. So what a vertical reflection is going to mean is that the graph just goes upside down. It just moves over the x-axis. We call it a reflection. Okay, so to begin with, we're going to graph negative absolute value of x. We start by doing just the absolute value of x, okay? So what I'm going to do is I've given you these x values to use. All you're doing, and you're doing this in your head, the absolute value of -2 is 2. Absolute value of -1 is 1, 0, 1, and 2. Okay, so that's going to be what we call our first graph, and I'm just going to graph that in red. So go ahead and do those points. We got -2, 2, -1, 1, 0, 0, 1, 1, like that, and just connect the dots. And just usually I like to use a dashed line to represent what we call the elementary function. And I'm going to label that y equals absolute value of x. So you start by graphing the elementary function, okay? Now, whenever you have a negative in front of a function, it changes the y values to opposites, because what it's doing is it's taking the answer to the absolute value and just multiplying it by -1. So you do this in your head also. So you just do 2 times -1 is going to give you -2. 1 times -1 is -1. So all this is doing is it's simply changing the signs. That's it, okay? Now, when you're plotting these points, you're still using the same x values, but the y values are different now. So you got -2, -2. You're just finding all of these dots are flipping over the x-axis. So I just plot the points like this, okay? And then you can do that from there, and that's what your graph looks like, and I'm going to label that y equals negative absolute value of x. So whenever you're doing this kind of transformation, this is the easiest transformation the students learn, is that thing right there takes a graph and flips it over the x-axis. It's because the y values go to opposites. Okay, so we've been practicing domain and range. Look at my green graph, this one right here. What do you think the domain is? From here to here, what is that? Forever, forever, negative infinity to infinity. How about the range? The range of the green graph. Don't look at the original. What's that doing? Way down here, negative infinity to what's that y value? 0. Remember, when you're doing range, you're talking about 0 y values. So write down your domain is this. Your range is negative infinity to 0 with a bracket. And the reason it's a bracket because it's included. There is a point in time when y becomes 0, like that, okay? So that's how all of these things are going to go, all right? We're going to kind of start these things off simple. Okay, the next one, the elementary function is y equals x squared, okay? And what we do is you square these x values. Again, do all this in your head, okay? So we got -2 squared is +4, -1 squared is 1, and then 0, then 1, then 4, like that. Okay, this is what we call the elementary function. We call this a parabola. So plot your points. You'll go left 2, up 4, left 1, up 1, 0, 0, right 1, up 1, and so forth. And then just kind of dash that like that. Just kind of going through those 5 key points like this. All right, so that's y equals x squared. Now what I'm showing you guys is why the math works. Because if you understand how the math works, you'll remember this. If you don't, if you just memorize it, you'll forget it the minute you walk out the door today, all right? So we know this is going to flip this over the x-axis. The question is why, all that does is that negative multiplies all those y values we just got by a negative. That's all it does. And when y values go to opposites, does that make sense that it takes everything over an axis? Okay, that's what's happening. Y becomes opposite. So now this you just do in your head. Okay, all right, so from here, what I'd have is just change these to opposites. So that's now -4, -1. You can't take an opposite of 0. That's still 0, and so forth like that. Okay? And then just plot your points. So you got -2, -4 would be left 2, down 4, -1, 1, 0, 0, and so forth. All those points are reflecting over the x-axis, and that gives you what your graph looks like. So that's y equals -x squared like that. Okay? All right. The domain on this, look at the blue graph. That can be anything. So x can be anything. We're only using, -2 to 2. It's just as a way to get the graph. We could go as far as we wanted to, and we'd always get a y value. The range is exactly the same as the first example. That's going from -infinity until you get to 0. Okay, so that's how that goes. Okay, is there any question? Real simple. This is a real simple transformation. When you have a negative in front of your function, the thing flips upside down over the x-axis. Okay, I'm going to let you do one problem. That's what we're going to kind of do today is I'm going to teach a reflection. You're going to do a problem. Okay? All right. Now, go ahead and I'll give you a few minutes to see if you can do that. Fill in the square root of x, and then fill in the negative square root of x like that. Okay? And we'll see if we get that okay. So first of all, the domain, you're going from 0 to infinity. On a square root, let me ask this question. This is important. How come I didn't use any negative numbers in my table? I chose these values for x. Why did I start at 0? Because you can't do a square root of a negative number, right? So if I put like -1 there, you would get an error on your calculator. You don't do square roots of negative numbers. That's why I started at 0 and went that way. And I picked perfect squares, things I knew the square root of. I just put the 2 in there because most of the time you'll get a decimal if you randomly pick things. Okay, so that's how your table goes. And then your graph, this is your original graph, and then it got reflected over the x-axis. Your range, I saw a lot of you doing that wrong. Remember, we're looking at this graph here. It starts down here, and then it ends up at 0. So it's -infinity to 0. Okay? All right, is there any question? Are we okay?
Can you explain why it's a bracket?
Say it again.
Can you explain the brackets for the 0?
Yes, because this is a definite point.
Okay.
If you look at your table of values, we definitely got 0. That's what. Okay. All right, let's go to the next transformation. The horizontal things are always harder for students. Okay, so let me kind of take you through what I'm going to call a horizontal reflection. And the first thing you need to look on this is there's something that makes this totally different than what I just did. See, the negative is inside of the function. All right, see, it's inside. It's inside of the cubing. It's inside the square root. When your transformation's inside, it affects x values. And you'll kind of see this theme as we go through all these different things. Okay, so the first thing that we'll look at on this one is the elementary function is y equals x to the third. Okay, that's the elementary function. So you just cube these things. So you're just going to do -2 to the third, -8. -1 to the third is -1. You multiply 3 negatives, you get a negative. Okay, you do 0 to the third, you get 0. 1 to the third, you get 1. 2 to the third, you get 8. That's your elementary function. Okay, so as we're doing these problems, we're going to learn our elementary functions anyway. Okay, all right, everybody okay? I'm just cubing the x values. All right, so plot your points. Go ahead and plot your points. You got -2, -8, -1, -1, 0, 0, 1, 1, and then 2, 8. Okay, you can use a dashed line. You don't have to use a dashed line. I just kind of do that to represent that that's the original function. And I like to label that y equals x to the third. Okay, that's what a cubic function looks like. Okay, now this is totally different, okay? Because the negative is with the x, what it does is it changes the x values to opposites. The problem you just got through doing, the y values went to opposites, okay? This is going to be kind of a theme. That's the reason why I didn't do another row on this table, because the x values change. So here's what you do. Go ahead and just write the same y values down. -8, -1, 0, 1, 8. They don't change, okay? It's always the opposite variable kind of changes. Now take your x values and change them to opposites, okay? So that -2 becomes +2. That -1 becomes +1. 0 is still 0, and then this 1 becomes -1, and then that 2 becomes -2 like that. So again, what's happening is it's the x's that go to opposite, not the y's. It's just totally backwards of what we just got through doing, because that's what the problem says. It says whatever x is, take its opposite, then cube it. Okay, that's what it's saying. Okay, now go ahead and plot your points. So just plot these points that we just did. So if we do this, we will have like 2, -8. So go over 2, down 8. We have 1, -1, over 1, down 1, 0, 0. Then we have -1, 1. And then we have -2, 8. And then connect the dots. That's what your final new graph looks like. I'll label that as y equals parentheses -x⁻³. Now I want you all to look at this. Okay, what happens on this problem is this thing right here, if you're doing this, it's reflecting over the y-axis, okay? So can you imagine in your mind just taking this graph and folding it over the y-axis? Don't these things come together? That point moves there, that point moves there, and so forth. You see what I mean? Okay, all of these x's change to opposites. That's what happens, okay? So that we call a reflection over the y-axis, a horizontal reflection like that. Okay, what's the domain you think of the second graph I got? Where to where? This way to here, left to right. Where's that going to be? -infinity to infinity. Good. How about the range? Looks like the thing goes up forever. Looks like it goes down forever. So what's that? There you go. Thank you. -infinity to infinity. Okay. All right, good. So that's it. Okay. So these things are all going to be kind of done the same way. Okay. All right. Let's look at what happens on the next one. All right. Now, again, the elementary function is just the square root of x. We're changing it by putting that negative under the radical. Okay. So we're going to go ahead and do this square root just like we did before. Do this in your head. You don't have to write anything. It's just square root of 0 is 0, square root of 1 is 1, square root of 2, we did that a minute ago. Calculator got 1.4, square root of 4 is 2, square root of 9 is 3, like that. Okay, and once you get to know these elementary functions, you won't spend much time on it. Go ahead and plot your points. So we got 0, 0, 1, 1. I'm going to go to the 4, 2. I'm not going to do the decimal one. And then over 9 would be a little further out, then up 3. Okay, and that's like the problem I just had you all work out. Okay, so we have y equals square root of x. Okay, that's it. Okay, now what happens on this is it's the x's that go to opposites. That's what the problem says. All of these x's go to the opposite, but the y's are unaffected. They're totally unaffected. So just like the last problem, just write down the y values. Don't change those. Just bring them down. That'll be 0, 1, 1.4, 2, 3, like that. Okay? Now change all of your x's to opposites. So we have 0, still 0. The 1 becomes -1. The 2 becomes -2. The 4 becomes -4, and so forth. Okay, so again, what I want you to notice is it's the x values that are going to opposites in this problem. Okay? Y stays the same. And that's the way it will always be, by the way. One variable will stay the same, the other thing will change. You got to get that kind of straightened out in your mind as you learn this. Okay, now if we go through and graph this, we have the point 0, 0, still the same point. We have negative 1, 1. You have negative 4, negative 2. Then you have like negative 9, 3, like that. Okay, then just kind of connect the dot, kind of like that. So that's y equals square root of negative x. Okay, so what happened to these x values? They all went to opposites. If you take your graph and fold it over the y-axis, this matches that, doesn't it? That's what we mean by reflection across the y-axis. Okay, does that make any sense? There's nothing to it, really, if you follow the procedure of how to do this. You just have to understand to have a way to keep from forgetting this. That's what that problem says. X becomes opposite. Okay, that's what that says. Okay, what's the domain you think of the green dart graph that I just drew? Where to where? Negative infinity to 0. Good. Okay, what's the range? 0 to infinity. Good. Okay. All right. So let's write down that, and I'll let you guys work on the next problem. So domain would be parenthesis, negative infinity to 0. Range would be bracket 0 to infinity, like that. Okay? All right, so I'll let you work on the next one, see what we get. Now, let me mention something on this because a lot of you may not know this well. What number, what a cube root means, what number do you multiply out 3 times that gives negative 8? Do you know what that is without looking at your calculator? Not 2, but negative 2, okay? You can do a cube root of a negative number because negative 2 times negative 2 times negative 2 is negative 8, okay? All right? Square roots, even roots, you can't do even roots of negative numbers. That's what you got to think about and understand, okay? All right, go ahead and see what you can do on this problem then. See if you get it right, okay? So I'm going to keep doing this new transformation 1 problem, all right? And we'll put this all together. Those of you who are going to take like pre-calculus next semester or trig, you'll do a bunch of, put the answers up and let's just kind of make sure that we're doing that right. One thing I noticed a little bit is, label which graph is which. I mean, I usually use dashed for the elementary. This is your elementary function right here. And then all that happens on this, see, is every point on this elementary function moves over here. The 8 becomes negative 8. This point moves over there and so forth. That's it. So you get reflected over the y-axis, okay? And then the domain and range are both all real numbers on both of those. The graph goes on forever in both directions, and same thing with y, okay? Yeah.
For the second line,
I may be off on this point right here a little bit. That's a point 1, 1. So that should be. So your point should be 0, 0, 1, 1, and 8, 2.
For the y, the negative has to be inside the.
Oh, thank you. Yes. You are right about that. I just didn't write that correctly. So that would be like cube root of negative x. Go like that. Okay, so if you follow the directions of how to change x, there's absolutely nothing to it. Do you agree? Yeah, okay. But you got to understand, that's what students do. They forget. All this problem says is x is going to opposite. That's what it says, all right? So it's the x that changes, not the y. All right, okay, so let's move to the next thing here. And now what we're going to look at is what we call a vertical transformation. Okay, now it's all where the number is. Okay, what I want you all to notice on this is this 2 is not adding to x. It's not doing anything to x. It's doing something to y. Notice on this, that 4 right there is taking the entire graph. You're going to find these things are going to take things up and down. So let me explain why that is. Okay, so the first thing we want to do on this problem is your elementary function is the x squared. Okay, so your first row, do it in your head. Do it fast. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay, plot those points. You'll get real familiar with these shapes. So you got left 2 up 4, left 1 up 1, 0, 0, 1, 1, and then 2, 4. Okay, and I would just label it. Get used to labeling them so you don't get these things confused. So that's your elementary function right there. Okay, now all in the world that's going to happen is we're adding 2, but we're adding 2 to the y values. Okay, so in your head, you just start taking all these y values and adding 2 to them. You don't need to write this down unless you need this as a record for yourself, but I'm really just doing 4 plus 2 is 6. Then I'm doing 1 plus 2 is 3, 0 plus 2 is 2, and so forth. So all of these y values just need to get bigger by 2. That's what that says. Okay, so we got 1 plus 2 is 3, 4 plus 2 is 6, like that. Okay, that second row, the y values get bigger by 2. All right, now if you plot your points, you're going to have this. Negative 2, 6, so you go to the left 2 up 6. So I'm going to do that. Left 2 up 6 is a new point. We have negative 1, 3, so you plot that. Then we have 0, 2, and then we have 1, 3, then we have 4, 2, 6, and so forth. Okay, so this is your new graph right there. Okay, can you guys see that everything moved up too? Right, that's what happens on this problem is that makes all the y values bigger by 2, and if y gets bigger by 2, it goes this way. Okay, all right, the domain, what's the domain of my second graph? What's x doing in my second graph? Where to where? Negative infinity to infinity, right? How about my y? Where's my y going?
2 to infinity.
2 to infinity. 2 to infinity. Starts at 2 and then gets bigger, okay? All right, so what we get here is this is negative infinity to infinity, and then bracket 2 to infinity like that. That's it, okay? All the points go up 2. All right? So let's go to this next one then. So our elementary function on this one is y equals x. What's y equals x? What we're doing is we're subtracting 4. This is going to make the graph go down 4. That's what's going to happen. The minus 4 makes all the y values get smaller by 4. Okay? When you do y equals x, all that means is that x and y are the same. So just these numbers are going to be the same. Negative 2, negative 1, 0, 1, 2, like that. This is going to give you a line, okay? So if you plot your points, you'll have negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2, like that. So this is an elementary function. That's just a line, y equals x. We call this the identity function, okay, like that, okay? Now, what am I going to do with all these y's? It tells you right there, y is x minus 4. So you do negative 2 minus 4, negative 1 minus 4, 0 minus 4, and so forth. I just add in your head. Don't get your calculator out to do that. Okay, so we got negative 2 minus 4 is negative 6. Negative 1 minus 4 is negative 5. And then this would be negative 4. And then 1 minus 4 would be negative 3. 2 minus 4 would be negative 2. Okay, that's going to cause everything to go down 2. Okay, plot your final points. You're looking at the original x values on this. And let's see what we get. So we have negative 2, negative 6 now. All these points just go down 4. We have negative 1, negative 5, 0, -4, 1, -3, and then 2, -2. Okay, just connect the dots, and that gives you y equals x minus 4. Okay, that's it. Everything goes down 4, right? So the domain on this is going to be all real numbers. X can be anything, so can y. The graph goes on in both directions, both ways. That's how that goes. Okay? So how did I know the first one went up 2? Just by looking at the problem. How do I know it goes up 2? Because adding makes something get bigger, right? How do I know the next one goes down? Minus makes it get smaller, right? Okay. That's what you're going to learn to see is just quickly what's going on in the graph. Okay. All right, let's try this one. See what you can do on this one. And think about what you need to do with x's. And then we're going to try, towards the end of class, try to put as much of this all together as we can. So what you're looking for in a vertical stretch shrink, if you look at these two examples, okay, first, I need to turn this thing, plug this thing in. You want to look at where the number is, okay? I mean, this one is an absolute value. By now, I'm hoping that you've got on the absolute value is the v, right? Okay, where is that number? That number is outside of the absolute value. So it's the y's that are going to change, okay? If that was inside of the absolute value, it's the x's that'll change. So it's all when I say inside out that's kind of important. So what you're going to find is this number in front, I'm just going to call that k. And I'm going to show you how this works, and it's arithmetic. Once you understand the arithmetic, then it's very logical how this works. So k is just going to be this number 2, like that. So we're going to start the way we've been starting all these problems. We're going to fill out the absolute value of x, so that's just 2, 1, 0, 1, 2. Okay, then go ahead and graph it like we've been doing. So we have left 2 up 2, -1, 1, 0, 0, and so forth. Okay, and then just kind of get that sketch, kind of doesn't have to be totally perfect, but you definitely want to get those first points in there exactly as they go. All right, now here's what happens on this. Okay, just think about this because you want to understand this stuff. That's what I want you all to be able to do. If you plugged 2 in, just look at this. If I plug 2 in, I'm going to get the absolute value of 2 is 2. Then what am I going to do with that 2? I'm going to multiply, right? That says 2 is multiplied by that absolute value of x. So that's what we're doing. We're going to multiply every one of these numbers by 2. Okay, that's what it's saying. Okay, so you can do that in your head if you want to. So just do 2 times 2 is 4. 1 times 2 is 2, 0 times 2 is 0, and then 1 times 2 is 2, and then 2 times 2 is 4. Okay, that's what the problem says, multiply by 2. 2 times the absolute value of x. So now if you plot these points, you'll have the point -2, 4. Now remember, look at the original x value when you're doing this then. So we got -2, 4. We have -1, 2, 0, 0, 1, 2, and then 2, 4 like that. Okay, now what happens on this is something a little bit different. We call this a vertical stretch. That graph didn't move up, did it? It didn't move up. It didn't move left or right. Imagine that this absolute value is like rubber bands. Can you imagine stretching on the rubber bands to make it into that new graph? That's what happens, okay? That just makes the y values multiplied by 2, so it stretches it. So what we're going to find on these problems is that number right there. If that number is bigger than 1, then these y values are going to get bigger, therefore it stretches. If that number was like 1/3, it would make them get smaller, okay? So you want to kind of understand how the math works. So with this one, the domain is going to be all real numbers. The range, okay, we start at 0 and we get bigger. Okay, so that's it. You've got to understand why we're multiplying by 2. Reason is because that's what the problem says, right? Okay. All right, let's do the next one here. we're going to spend a little bit more time on stretch shrink because the horizontal stretch shrink is kind of troubling sometimes for students. Okay, so what do we do? Square root. Just do this real quick in your head. Square root of 0, square root of 1, square root of 4, square root of 9, square root of 16. Okay, plot your points. So we got 0, 0, 1, 1, 4, 2, 9, 3, and so forth. Okay, all right. Now, okay, what am I going to do? What does the problem say to do with the 3? What am I going to do with the 3? I'll multiply by 3, right? So take those numbers and multiply all of those by 3. Okay? Do that in your head. Write it down if you need to. 0 times 3, 1 times 3, 2 times 3, 3 times 3, 4 times 3. Okay? Those numbers are getting bigger. That's what's causing it to stretch. So now if you go through and plot your points, it looks like we got 0, 0, same point. You got 1, 3. Okay, and then you got like 4, 6, so over 4 up 6. And then 9, 9, so that's just kind of like way up there. I guess 9, 9, you can kind of estimate where that is. So once you get those points plotted, you get y equals, that would be y equals 3 absolute value of x like that. Okay, so you can see that it's stretching. That's a rubber band. You're just pulling on them. It stretches it upwards. Why does it stretch? Because 3 makes the numbers bigger. Okay, bigger means stretch. Okay, all right. Domain on this one would be start at 0, go infinitely to the right. Range would be the same thing. Start at y equals 0, get infinitely bigger. Okay, does anybody have a question? Okay, I have observed no problem so far today doing the elementary function. So let's see if we can do this next problem okay. I think you should be able to do this one fine. Now, here's a cube root. I made the same mistake I made a minute ago. So make this change. Don't use -2, use -8, and don't use 2, use 8, because the cube root of 2 is a decimal. Okay, I wrote those perfect cubes on the board, so those are kind of good numbers to know or be able to figure out, okay? All right, so let's see what we can do on this. And let's see, domain and range were all real numbers. Then you're just doubling, you're multiplying the y values by 2, okay? All right, so that's solid, okay? And you're going to kind of see a theme when we go to, we're going to do kind of another set of these same kind of problems that are going to be slightly different. Any questions about what I've done? Okay, all right, very good. Okay, now we're going to look at what we call a vertical shrink, okay? Look very carefully at the problems that we're getting ready to do and look at what the difference is. The idea is the number is outside of the function, outside of the absolute value of x, outside of the square root of x. What's the difference with these numbers? What were the numbers on the previous page? Like 2, 3, they were bigger than 1, right? And you multiply it by a number bigger than 1, something gets bigger. What happens to a number if you multiply it by a half? Does it get bigger or smaller? It gets smaller. You cut something in half, it gets smaller. That's what causes these things to shrink, okay? All right, so let's go ahead and just do kind of the same thing. Fill out your first row quickly. Absolute value of -2 is 2. Absolute value of -1 is 1, and so forth. So here comes this V shape again. Okay, so we have this. Now, like I say, when we're doing our test in a couple of weeks, you're going to do your graphs without a graphing calculator. It's the only way I can get people to really learn how to graph. Because you just put it in your calculator and not learn anything. That's important to me. Okay, so we got that. Now, all you're going to do is multiply these numbers by a half. You can cut them all in half in your head if you want to. So if you take half of 2, that's going to be 1. If you take 1/2 times 1, that's going to be a half. If you take 1/2 times 0, that gives you 0, and so forth. You don't have to write down what arithmetic you're doing. You just need to know what you're doing. Okay, so the next one we do a half times 1, that's a half. And then if we do a half times 2, we get 1. So all of those numbers got cut in half. That's what it means to multiply something by a half. Okay, so go ahead and plot your points. So we have -2, 1. We've got -1, 1/2. Just estimate it. -1 half. 0, 0. Then we got 1, 1/2. Then you got 2, 1, like that. Okay, just kind of connect the dots into that same kind of V shape like that. Okay, now you're not stretching on the original one. You're not pulling on the rubber band. What are you doing? You're shrinking it, kind of like compressing it. Sometimes we call this a vertical compression because you're making that thing go down. Okay, all that happened is we multiplied by a half, all those y values got smaller. That's why it shrinks. Does that make sense? Okay, understand the arithmetic, and you won't forget it. Okay. All right, so the domain on this is all real numbers. Range is 0 to infinity. Okay, the range starts at 0, the y values get bigger. Okay. All right, next one, the k value is a third. And again, if you multiply a number by 3, you're going to make numbers get smaller. That's why things are going to shrink. Okay. All right, so just do your first row in your head. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Okay, you want to always do these elementary functions fast and efficiently. Okay, so we got 0, 0, 1, 1, 4, 2, 9, 3. Don't have to worry about the 16, 4. But, you know, these x values get bigger forever. So that's your elementary function right there. Okay, now we're just multiplying everything by a third. Now, you don't need to get your calculator out. I know a lot of students are going to want to do this. You don't need to do that. You do a third times 0, you get 0. Okay, if you do 1/3 times 1, you get 1/3. Now, this is where students start sometimes messing up. If you do 1/3 times 2, okay, what do you do with fractions? You multiply them straight across. So that gives you 2 over 3. So that becomes 2 over 3 like that. Okay, then when you do 1/3 times 3 over 1, that's 3 over 3. So that gives 1 like that. Okay, I'm cutting those things in thirds. Okay, think of it this way. It's helpful to you. It's just like 1 divided by 3, 2 divided by 3, 3 divided by 3. This would be 4 divided by 3, so it's 4/3. Okay, a fraction arithmetic is going to pop up from time to time. Okay, let's see if this thing looks like it shrinks stuff to us. So if you get your points, we have 0, 0. We have 1, 1/3, just estimated, okay, just it's a little bit above the x-axis. Then you have 4 2/3, again, a little bit between 0 and 1. Finally, you get to 9. 9 is up 1. Okay, so the graph is kind of just barely above the x-axis like that. Okay, so it shrinks. Okay, the graph shrunk, it flattened out. That's how that goes. All right, then the domain. What's the domain on this square root function? Where does it start? 0. Does it ever end? No. How about the range? Where does it start? 0. And remember, range is y values, so it's the same on that. Starts at 0, gets bigger. The graph doesn't look like it gets bigger forever, but it does. It just takes forever for it to get real big. Okay? All right, so let's do the next one here. And again, with this one, you're multiplying your y values by a 4. That's what causes this graph, when you draw that, to flatten or shrink. Okay? Okay, do we have questions on anything there? Okay, so we've learned a bunch of transformations. We got really one more to look at, and then, you know, what we'll be kind of looking at is then trying to put this all together. Okay, all right. Now look at this. I go to horizontal. That's what I'm trying to get you to make sure that you understand. The 1/2 is inside now, right? On the page we just did, those numbers were outside. Look at example 2. The 2/3 is under the radical. So what that means is if the number is with the x inside the function, the y's stay the same, but the x's change. That happens every single time when you're inside the function. Okay? All right. So let's see, this one, again, the way I teach these, I don't do like 2 rows on my table because the y's stay the same. It's the x's that change. Now, this is the one that's probably the hardest for students to grasp, so watch carefully. What you always do by this is you end up multiplying the x values by the reciprocal. When you do these horizontal things, everything's backwards of what you think. Just like when we did left, right. If we had x plus 4, that was left. If we did x minus 2, that was right. Everything is totally backwards of what you kind of think intuitively that it would be. So in this problem, k is the number that's changing everything. So that's 1/2. Okay, so the elementary function, I think we're not having much trouble with that. Okay, this would be 4, 1, 0, 1, 4. So go ahead and plot your points. So we have -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And that's y equals x squared. Okay, all right, that's not hard for anybody. We're doing that fine. Okay, now this time, same thing. What do? The y values stay the same. If your transformation is inside of the function, the y's stay the same. Just write them down. 4, 1, 0, 1, 4. That's not what's impacted on this, okay? All right, now watch carefully how I do this now. So what you do is you take each x value and you multiply by the reciprocal, okay? It's backwards of what you feel like it would be. So we're going to take that and multiply that by 2 over 1. So we end up getting -4. That's your new point. Okay, we're going to do that every single time on this. The next x value is -1. We're going to take -1 times 2 over 1. So that ends up being -2. The only way you really can make sense of why this is to check your points, which I'll show you here in a minute. Okay, then we go to 0. 0 times 2 over 1 is 0. And then same thing, we do 1 times 2 over 1, that's 2. And then finally we do 2 times 2 over 1, that gives 4. Okay, so those are going to be what our new points are. So the y stayed the same. Again, it was the x's that got multiplied by the reciprocal. Okay, what students always think is we cut those in half. No, it's opposite. Opposite of cutting in half is doubling. And if you look at all those x values, they all double. So you're multiplying by a reciprocal. That's the one I think is the hardest to remember for students. So now when we go through and do this, plot your points. So we have -4, 4. Then we have, not -4, 4, I'm sorry. -2, -4, 4. I am right. Confusing myself. Yeah, so we have -4, 4. Then we have -2, 1. And then we have 0, 0 still. We have 2, 1. And then we have 4, 4, like that. Okay? Now, here's what you have to understand on this. This is called a horizontal stretch. Now, horizontal is this way, right? So does it make sense? You got your parabola, rubber band, you're stretching it this way. That's what happened, is that stretched this way, okay? We're talking horizontal because we're affecting x. X is a horizontal measurement. That's what that is. Okay, so what we have for our domain is all real numbers. Our domain, we keep getting a lot of the same things. That's 0 to infinity like that. Okay, let's go ahead and wrap up class with this example too, and that'll at least kind of get us started on this. Then we'll get all this stuff wrapped up next week. Okay, so do your square roots. So we have the next example, k is going to be 2/3. So we got 0, 1, 2, 3, 4, just doing the square roots of each of those numbers. This is a square root function. So we're not there yet.
Oh, okay.
We always kind of start by doing the elementary function, okay? So we're just disregarding the 2/3 when we start it. So we got 0, 0, 1, 1, 4, 2, and then 9, 3. Okay, so we got y equals square root of x as our elementary function, okay? All right, so what stays the same? Y stays the same, so just rewrite those y values, 0, 1, 2, 3, 4. Okay, we're not changing y, we're changing x. Now, what I said to do on this is it's backwards of what you think. Students want to think that you're multiplying by 2/3. No, the opposite of multiplying by 2/3 is multiplying by 3/2. So I'm going to do 0 times 3/2, okay, which is 0. And again, I'm multiplying the x values now. It's the x values. So that's still 0, 0. Then I take 1 times 3/2. That's 3/2, which is 1.5. I'm just going to write that as 3/2. Then I do the 4 times 3/2. Well, that's 12/2, so that's 6, like that. Okay, then we take the 9. 9 times 3/2 is 27/2. I'm just going to write it like that. You could change that to a decimal, but we're kind of getting out of room on this anyway. Okay, and I'm not going to do the last one because it's out of room anyway. Just forget it. Okay, so now if I go through and plot these points, what I'm going to have is I still got 0, 0. I've now got 3/2, 1. And remember, that's 1.51. So just go over 1.5 and up 1. Then we got 6, 2, like that. And then we got 27 over 2. I think 27 over 2 is 13.5, and then 3 like that. This one doesn't look like it's affected much, but it's a little bit under that graph like that. Okay, so that's how it goes. All right, this one you would end up having the domain is going to be 0 to infinity. The range is also 0 to infinity like that. Okay, now before I finish this up, I want to show you the checking. Now, this is real important that you see this. Okay, I'm just going to take one of these points. I'm going to take this point 6, 2. Now, let me show you why it's right. If I take my function and if I plug that 6 in for x, look what happens. We would have the square root of 2/3 times 6. That's the square root of 12 over 3, which is the square root of 4. Isn't that 2? So you can check. You can tell you're right. Okay. So you do that. That's how you ultimately understand what's going on with transformations, is checking. Okay? All right. Good job. You guys did good. You didn't act very excited today, but you did a good job in class. Okay. Well, it's almost the weekend and we're getting into the mid-semester slump kind of too. Do that homework.